This will be for the Khan Academy exercise Vectors Intro. So just some notes before we begin. The definition of a vector is that it has both a magnitude and direction. Okay, the magnitude will just be the amount, usually speed, but not always. So the vector is usually represented by a lowercase letter with an arrow on top. The arrow always points to the right. Okay, this is not array because it does not continue forever, but we'll get into that later. And if you see the double bars on each side of the letter, that refers to the magnitude of that vector. So this right here would be the magnitude of vector A, and an example of that would be the magnitude of vector A equals 55 miles per hour. Okay, notice there is no direction here. It's just the amount of the velocity or speed. So many of the problems in this exercise will refer to the directional compass. Okay, remember, when you travel up, that's north. When you travel down, that's south. When you travel right, that's east. And when you travel left, that's west. Okay, so it says Dakota is riding her bicycle. At a certain time, her speed is 35 kilometers per hour, and her direction is 50 degrees to the east from the southward direction. So they list some of the vectors on the graphs. Okay, and they're basically saying here that the magnitude of vector A, B, C, and D, they all equal the same amount or the same speed. So let's look at the graph. Okay, here's the graph, and here's vectors A, B, C, and D. They want to know which vectors can represent Dakota's velocity. So before we go to our multiple choices, I would like to do a rough sketch of the vector. Okay, so here I drew a graph with the directions labeled north, south, east, west. Okay, and it says her direction is 50 degrees to the east from the southward direction. Okay, so if we started in the southward direction and went 50 degrees to the east in this direction, the angle would be 50 degrees from the south. See, it says 50 degrees to the east from the south. So you start from the south and you go 50 degrees in the eastward direction. Okay, so basically this is the direction that the vector is going to be pointing. Okay, now does it need to start at the origin? No, it just needs to have this direction that's 50 degrees east from the south. So there might also be a vector that starts here. Okay, as long as it's 50 degrees to the east from the south. So this is what the vector would look like. So let's see which ones point in this direction. So looking at the graph, going down to south this way we said was east. So we can see vector B is 50 degrees east from the south direction. A is not, so B is good. And right here also D is 50 degrees east from the south direction. C is not. So you can see B and D fulfill the correct direction. And they just happen to be the same length because they are the same magnitude. So choose all answers. It's going to be B and also D. Okay, it says particles A and B are moving along in a plane. Their velocities are represented by vectors A and B respectively. Which option best describes the meaning of the following statement? Okay, remember that when you have the double bars on each side of the vector, that is just magnitude. So this right here is just saying the magnitude of A is greater than the magnitude of B. Now, A and B are velocities, okay? They have both magnitude and direction. But without the direction, the velocity is just speed, okay? It's just going to be a number, like let's say 35 kilometers per hour, okay? The speed is the velocity, but without the direction. So here they're just saying the speed of A is greater than the speed of B. It's just going to be a number without the direction. So let's look at the choices. Okay, particle A is heavier than particle B. No, there's nothing about weight in the problem. Particle A's speed is greater than particle B's speed. Well, yes, we can see A is greater than B. Of course, the arrow always points to the less than side. Answer C, movement creates a greater counterclockwise angle. No, that's ridiculous. So that's it, answer B. Okay, it said a boat is traveling at a speed of 50 kilometers per hour in a direction that is 45 degrees to the west from the north. Here are the vectors. They're all equal magnitude, 50 kilometers per hour. And they want to know which can represent the boat's velocity. So like we said before, you don't really need to worry about magnitude on this type of problem. Okay, here's the graph with the directions labeled. They say the vector is 45 degrees to the west from the north. Okay, so you start from the north and you head 45 degrees to the west. Alright, so that would basically look like this. Right, if you started from the north and went 45 degrees to the west, this is the direction of the vector. Okay, now like we said before, it doesn't have to start at the origin. Okay, it might be down here like so, but this is the general direction of it. So let's see our choices. Okay, we could see choice A is headed to the east. That's no good. Choice B, this is the north. It's 45 degrees to the west. So B is good. Answer C is headed south. Southeast. So that's no good. Okay. Since we said B was correct, which ones are similar to B? None of them. Okay, so B is the only one that is 45 degrees to the west from the north. Any of these other vectors, they can start wherever they want, but they have to be pointing in this direction, or else it's not equivalent. So B is the only one. Okay, it says mice A and B each went on a quest to find food. Their displacements by the end are represented by vectors A and B. Which option best describes the meaning of the following statement? Okay, so it says A and B are vectors representing displacement with a double bars on each side. That's going to be magnitude only. Okay, and since the vectors represent displacement, the magnitude of the vectors is just going to be the distance. Alright, so it's going to be distance only. So it's not going to include the direction they went, just the distance that they traveled. Alright, so it says they're equal. Let's take a look. The mice finish at the same distance from their starting points, but not necessarily same direction. Yes, that's true. Mice finish same distance and same direction. No, this was magnitude only. Mice walk the exact same path. No, definitely not.